Okay, we just finished in the last section talking about those measures of central tendency. So that was like one number to describe the data set. And you're going to see today that you're going to want a second piece of information about a data set to really know what's going on in it. So that leads us into section 2.4. We'll be spending 2 days here. The first thing we're going to do is look at a data set actually 2 data sets. We're going to be looking at the starting salaries for 2 different corporations. And they each hired 10 graduates, so this is a population of their new graduates and what their starting salaries were. So to organize this a little bit more, we're going to make a back-to-back stem and leaf for these, a double stem and leaf at that. So if we look, so we need to know what our stems are going to be. So we got 40s, 30s, 40s, only 40s and 30s here. Here we got a 20 in the 50s. So because of this one's got the more spread out here, so we need to go, let's put corporation B here, and we're going to do this back to back. So our stems are going to go down the middle, and then the leaves are going to grow out left and right. So corporation A. And we're doing a double stem, so we'll put the 20s, 30s, 40s, and the 50s. Okay, now I have taken the time to put them in a list because we're going to need it later on. And I sorted them. So this one is Corporation B. If you can see those. We've got a starting salary of $23,000. Then $29,000, 32. Remember how the doubles work. Anything 0 through 4 on the first one and 5 through 9 on the second one. 32. Let's see, I got the 32, so we're at 40. 2 41s, a $49,000, and a 50. A 52, and then a 58. Okay, then Corporation A got on this calculator, and I sorted them. So they've got 37,000 starting, 38, 39. Looks like 341s. 42, 44, 45, I'm writing in the wrong spot. 42, 44, 45, 47, and that's our last one. So, if you look at these, they don't look very similar to each other. These are all crunched together. These are way spread out. If I asked you which corporation would you rather work for? Well, that's kind of an individual question. You want to be guaranteed something? Or do you want to be confident in yourself and think, boy, I can come start out at 58,000 here versus 37,000 here? So that's a kind of an opinion question. But what I want to do is look at the average salary for each one, the mean, the median, the mode, and see how different they are there. So, because I've already got them in the list, we're going to be using the shortcuts for that. 1 second, get rid of that. Okay, so we want the mean salary for both of them. So, the median salary and the mode salary. So I will do both of them at the same time. Quit. Here we go into list, over to math. I want the mean salary first for that corporation. Over here, same thing. Quit. List, over to math. The mean for list 1. Oh, okay, so both corporations have the exact same average starting salary. And remember, these are in thousands of dollars. Now we want the median salary. That's going to be the middle one. I could count, or I can go in here. Median is number 4 for list 1. $41,000. The median for list 1. $41,000. Kind of very similar. And the mode salary is the one that occurs most often, and if you look, this one's got $41,000. Again, 341s there. Boy, so if you were to be given information about these two corporations, and all you looked at were the measures of central tendency, here's Corporation B and here's Corporation A, you're thinking, boy, doesn't matter which one I work for, they're kind of the same thing. But once you see the stem and leaf, you say, boy, they aren't really the same at all. This one, over here at Corporation B, I got a chance to make a very minimal salary. Or I've got the chance to make a really high salary. Over here at Corporation A, I'm kind of guaranteed something kind of right in the middle of the road here. So it depends on how you're feeling, which one you want to go for. So really, the second descriptor you need to know about a data set is how spread out those values are. This one's way more spread out. This one's a little more compact. They're all close together in comparison to this one. So when we talk about how spread out the data values are, those are called measures of variation. How much variation is there in the data value? A small variation means they're all close together. A big variation means they're all spread out. So that's what the focus of section 2.4 is going to be, is on ways to describe how spread out data values are. So the big ideas today are measures of variation. And again, the number that we get is going to be an indicator of how spread out. Okay, just like we had 3 measures of central tendency, we have mean, median, and mode, we've got 3 different ways to tell how spread out things are. And some are better than others. So the first thing you can do to tell how spread out a data set is give the range of numbers.
Immediately, not tomorrow, no.
Okay, range is just your max minus your min. Okay, so we'll go back up there in a minute and do range. Actually, let's just do it right now. So let's give the range of Corporation A. So their range of salaries, you take your maximum salary of $58,000 minus the minimum salary of $23,000 and we get a range of $35,000. So there's a $35,000 difference between your lowest salary and your highest salary. Where over here at Corporation A, our maximum salary was $47,000 and our minimum was $37,000, so there's only a $10,000 range. So you can see a smaller range should indicate a more condensed set, but if you think about it, we do tend to occasionally get outliers in our set. And if we had one outlier, say somebody down here was at 20,000, you would have a big range, but you'd see most of them are all up high. So range would not be a good option for range would not be a good option to describe the variation if you had an outlier. So to fix that, we have 2 other measures of variation. One is called variance, and the other one is standard deviation. So variance And there's a whole big process to get this. And then standard deviation. So I need a whole page to talk about variance. All right, so variance. For a population data set, because it's going to be different for a sample. Okay, and we do have the symbols we're going to start introducing. The symbol for population variance, back to Greek letters, it's lowercase sigma with a squared on it. And the squared's going to make sense a little later on. So, the formula to find population variance. Okay, so what we're going to be doing, and it's a longer process, and we're going to let the calculator do a lot of the work for us, but here's the way it works. What we're going to be doing is finding the average, which we did already, and then we're going to see how far away every one of our numbers is from the average. So the first thing, leave a little space at the beginning here, we're going to take each x value and subtract the mean of the data set. Then we're going to take those differences and square each one. Then we're going to add all of those squares together. Remember from advanced algebra, sigma means to sum up. So we're going to get the sum of the squares, then we're going to divide by how many were in our population. So n is your population size. So it might look ugly, but it's not too bad. I'm going to list the steps out as we go through. I'm going to show you how to do it on the calculator. With whichever corporation this is. Let's see which one it is. What calculator is this? This is Corporation A. So, I'm going to take this formula and break it down into steps for you so you can look back and know what to do. So, the very first thing you want to do is enter all of your x values into a list. So, enter data into, and I'm just going to say list 1, but you can put them in any list you want. Then, if you look at the formula, I'm going to have to take each x value and subtract the mean. So the next thing you're going to have to do is find the mean of your list. So you're going to find the mean of list 1. And if you remember, I'll write it down, you're going to go under list on the calculator. Remember list. Go over to math, so I'll arrow over to math. And then do the mean. Okay, so you'll have the mean. And we already did the mean, so I've got the first 2 steps done already. Now the third step is to find the deviations. Oh, I didn't describe that at the top. Find the deviations when you take a value and find out how far away from the mean it is, that's called a deviation. So, and we're going to let the calculator do all of these subtractions for us. So remember, I had 10 numbers, but I could give you a list of 20 or 30, and we won't have to do all of them individually. So watch how handy this calculator is. So I'm going to quit. Remember, the average we already found was 41.5. So I'm going to go back to my list. Okay. Make sure you have list 2 cleared out. Remember, clear, good. So what I can do now is go all the way to the top. I'm going to tell the calculator to take all of these x values and then subtract 41.5 from them. And watch how I can do that. So I'm up here on the top. I'm going to go, say, take everything in L1. So second L1, subtract 41.5, because that was my average. I hit enter, and it just did all 10 of those subtractions for me. Okay, so we have the deviation. So what I just did, we'll put it down. This will be the reminder. Go to L2, say take L1 and subtract the mean. Okay. Now if you look at the formula, after you do the subtractions, you need to square every one of those numbers. So our fourth step is to square the deviations. I'll do it on the calculator, then I'll write back down what I did. Watch how easy. So remember, list 2 has my deviations. I'm going to go over to list 3, make sure that's cleared out. Then go up to the top. I want to tell it, square all of these numbers. Well, they're all in list 2. So I just tell the calculator, second L2, squared. The squared key is right here. Or you can use caret 2. Hit enter. And now it has squared all of those numbers. Okay. So what we just did was we went to L3 and we said take L2 and square it. Okay. Looking at the formula, we've done the subtracting and we've done the squaring. Now I want to add up all of those squares. We can use that list math to sum up a list. We did that before. So our fifth step is going to be to sum the squares so we're going to go under list, go over to math, look for sum, and the numbers I want to sum up are sitting in L3. So I'll do that. So I'm going to quit, go to list, over to math, sum is number 5, give me the sum of list 3, got it. Okay, and then our last step, according to the formula, is divide by my population size. So step 6 is to divide by, not on the screen, divide by population size. Once I do that, I will have the variance for Corporation A. So, I got to divide by I had 10 new employees, so I'll divide by 10, and I get a variance of 8.85. So if we go back, I did range, I want to stick variance in here, and that was Corporation A that I just did. So the variance, should have left a couple more lines there, is 8.85. But now I want to talk about the units that belong on there. Take a look at our formula. This was dollars minus dollars, so I've got dollars. Square the dollars. Now I'm at dollars squared. I add up all of my dollars squared. I'm still at dollars squared. Then I divide them into groups. My unit on variance is 8.85 thousands of dollars squared. Dollars squared don't even make any sense in this world. Okay? The reason we don't talk variance so often is because of the units are usually non-existent. So to fix that, all we've got to do is square root this answer. If I square root the answer, I'll be back down to dollars. So when we square root variance, we create standard deviation. Standard deviation is the most often used descriptor for how spread out a data set is. So, this was all of the steps to get variance, and now to get standard deviation, is just the square root of variance. Think about the symbol now. I told you why that squared would be here. If I square root sigma squared, I'm going to be down to just sigma. So the symbol for the standard deviation for a population is going to be just sigma. So, if our variance is 8.85 thousandths of dollars squared, the standard deviation is the square root of that, $2.97 thousand dollars. Okay, pretty small number when we compare it to what I'll get on Corporation B. And watch how fast I can do one of these off of the formula. I don't even need to look at the steps if I have the formula. Okay. I know the mean is 41.5, so I've got that, so I'm ready to start. Stat, edit, clear. So I say, formula says take all of my x values, subtract the mean. So I'm going to tell it L1 minus 41.5. Done. Go over to list 3, clear it out. Now I've got to square all of those values. They are sitting in L2. So I tell it L2 squared. Done. Now I want the sum of all of these squares. They're in list 3, so I'm going to quit. Go to list, over to math, sum L3. Got it. And then divide by my population size, which was 10. My variance for Corporation B is $110.25 thousand squared. So, when you compare variance here to variance over here, I'll use V. Well, I could use the sigma squared, but 110.25 thousandths of dollars squared. Again, look at how much bigger 110 is. That's an indicator that this data set's going to be way more spread out than this one. Now if I square root my answer, 10.5. The standard deviation, $10.5 thousand is the average distance from the mean. Because that's what we're actually finding is what's the average distance from the mean. And again, a 2.97 and a 10.5, this one's going to be more compact, closer together than this 10.5. Okay. And I did tell you there was going to be a difference between working with a population data set versus sample in terms of calculating variance and standard deviation. Yeah, got to get organized here. So, sample variance and sample standard deviation. The formula is just slightly different. So, sample variance okay, we did population variance. Population variance, the symbol was sigma squared. Sample variance, it's S squared. Okay, to calculate S squared, the numerator is exactly the same. You take each x value, subtract the mean to find the deviations, square those, add them up. Here's where the difference comes in. Instead of dividing by exactly how many are in my sample, we divide by one less than the sample size. Why? I don't know. That's the way it works. Way smarter people than me figured all this stuff out. So this is your sample size minus 1. It's the only difference. So the 5 steps will be the same. The last step is going to change when you divide by one less than what you have in your sample. Standard deviation for a sample, still the same connection. It's just the square root of that. So sample, standard deviation. Is the square root of sample variance so its symbol is going to be just down to S. And these symbols will become very important tomorrow. Okay, I want to show you how I want you to copy on your homework paper what I want you to do, because we're not going to write down all those lists. So I'll go through one more example of showing you what I want. So, let's go through just one of these. Right. Okay, number 11. It says find the range, the mean, the variance, and standard deviation of the population data set. So we'll do number 11. So first thing you got to do, or I'm going to do, so example 1 is number 11. You're going to put them in a list and sort them. Let me take the time. I should have done this earlier. So you can fast forward to this till I get it all put in, but let me get them in. Edit. Clear all these out because I'm going to need them. Okay. So 13, 23, 15, 13, 18, 20, 18, 17, 20, 13. Okay. So they're in. I want to sort them. Oops, stat, sort, list 1. Okay. So all I want you to do for homework now is give me the first and last numbers in your list. So stat, edit. Smallest was 13. Largest was 23. So we're going to make a little table. 13. And 23. Then I have to find the mean. Here's my formula. I got to find the mean. So you're going to quit. Let the calculator do the work. Mean 16.57. I think 2 places out should be pretty good to matching what's in the book. And write that down somewhere. 16.57. Now I want you to do all the steps, but I only want the first and last values copied down. You don't have to give me all the ones in the middle, because they're all going to be stored on your calculator, and there's no sense in writing all that out. So I'm going to go back to stat, edit, number 2. I'm going to say take everything in L1, subtract the mean that I just found, 16.57. Done. So all I want you to write down is the first one, negative 3.57, and then the last one. If those are right, everything in the middle's got to be right. Now we want to square those. So I go over, I say take everything in L2, square, 12.7449. 41.345. Then we gotta sum these up. So I'm gonna quit. Just math sum of L3. 143.4286. And then I have to divide by. I gotta know whether this is a population or a sample. The problem has to tell you what you're working with. If I look back at the directions, this was a population data set. Where down here, if it's a sample, you know what to do. So you got to look at the problem to see what you have to divide by. Because this is population, I'm going to divide by how many I had. I didn't really count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm going to take my number, divide by 14. I now have the variance. So the variance, I'll use the symbol, is 10.24. I will square root that to get my standard deviation, 3.20. And then it did ask for range in there, but you know how to do that. So all I want for homework is the two rows, the top row and the bottom row in your table, and I'll know everything else in the middle is good. So there it is.